Hi, thanks for joining me today. I've got an interesting functional equation problem. We want to find all continuously differentiable functions f from the reals to the reals such that for every real number x, f of x is positive and f prime of x equals f of x. Okay, so if you want to have a go at this problem, pause the video now and give it a go for yourself, and I'm going to dive straight into a solution. Okay, so let's look at the derivative of f. It's equal to f of x. And well, because f of x is always positive, regardless of what the input is, if I think of this as the input for this f, that tells me that this whole thing is going to be positive by the first bullet point. And therefore, f prime of x is always positive, which tells us that f is increasing. And therefore, f of x is always going to be going upwards. And well, we can combine this fact and this fact together. If f is increasing, that means for all, let's say, alpha beta, with alpha less than beta, f of alpha is going to be less than f of beta. And so now what if we use the fact that 0 is less than f of x? So here alpha is 0 and beta is f of x. This is going to tell us that f of 0 is less than f of x. And this here is just f prime of x. So this is true for all values of x. We found a lower bound for the derivative of f. It always has to be bigger than f naught. And now this is interesting because, well, if I write down this inequality, f prime of x is bigger than f of 0. And what I'm going to do is integrate this between t and 0, where t here is now going to be a negative number. So if I integrate this between t and 0, dt, and the integral from t to 0, dt, what do I get on this side? Well, I'm just going to get f of 0 minus f of t, and that's going to be bigger than this thing here, which is just going to be minus t times f of 0. And if I just rearrange this, what do I get? Well, I'm going to get 1 plus t, well, it's supposed to be an arrow there, 1 plus t times f of 0 is always bigger than f of t. Or in other words, f of t is strictly less than this thing here, and this is true for any negative value of t. But here you can see we're going to have an issue, because we know that f of 0 is positive by the first bullet point, and 1 plus t, if I make t equal to minus 1, for example, this whole left hand side is going to be 0. So I'm going to have that f of minus 1 is less than 0, but that contradicts the first bullet point. And therefore it is impossible to have a continuously differentiable function f from the reals to the reals which satisfies both of these two bullet points here for all real values x. Anyway, I hope you have enjoyed this solution video. Thank you for watching. If you are new to the channel, please do consider subscribing and do give this video a like as well. I guess if you stuck to the end, it probably means that you've enjoyed it. So please do give it a like. I'd really appreciate that. But yeah, apart from that, I will catch you on the next one. Have a great day.